It's an interesting perspective you sort of shared on PFAS in the sort of the warm-up call, but also because I think when I look at the PFAS solutions and where people see the innovation, it's quite sort of hard engineering, right? It's destruction, it's can be energy intensive, is actually to get rid of it by trying to break these so-called unbreakable carbon bonds. You know, they've been called forever chemicals, but actually talk us through how you see it from a kind of like nature and a like synthetic biology point of view. And actually it's kind of flipping the script a little bit on how you would treat PFAS, right?
It is. And it really goes back to what nature's good at. And there's a thing called the microbial infallibility theory, which states, and it's been proven, that nature evolves to break things down. It breaks them down to use in their metabolism. And so it's something that they need to survive. And so we've got lots of examples in bioremediation over time, where you've got organisms like Dihalococoides that breaks down chlorinated solvents. It does that naturally. And I was mentioning earlier, we started with breaking down 1,4-dioxane. Even though that one is not as regulated as PFAS, we found a natural organism that naturally breaks down 1,4-dioxane. That will happen with PFAS. Now, it takes nature a long time. And PFAS is a new chemical in the world of the environment. So it could take another, 100 years for nature to evolve to break that down, but eventually it will happen. It's happened with, everything else that we put in the ground that in similar ways. And so the interesting thing about synthetic biology is you can speed up time to have nature break that down faster. And so you can engineer biology so that it happens not in 100 years, but in 5 years. And if you think about the PFAS problem, we've heard it everywhere. It's everywhere in the world. It's in the Arctic and places that PFAS is not used or manufactured, is that doing an ex situ reaction is fine. We need to do that today, which means you're pulling it out of the ground, you're separating it, you're destroying it, and then you're using the water. But it's in every soil that we have. You can't do that with all your soil. So really the more elegant way to solve this is with nature, with the organisms that exist today or can exist in the future. And so I think the future of like cleaning up PFAS is using biology. It's going to take a while to get there. This is not easy science to do, but that's the way to have a sustainable long-term solution for really any of these emerging contaminants that exist today. And so it's an exciting time to be working in this space. Yeah, again, going back to this, you couldn't have done this 10 years ago. The tools didn't exist.
Right. How does that work then? Just from a very explain it to me. I remember we had a podcast with someone, and she said when she speaks to startup, she's like, explain it to me like you're talking to your grandpa or your grandmother. So when you're talking about let nature take its course and it will eventually break down PFAS, explain it to grandpa. Are you saying you're basically an additive
that's him, not me.
Yeah. Explain it to the grandson. No. But what are you, how are you talking? So basically, if there's a field and soil and essentially there's, like you mentioned, PFAS is everywhere, are you putting an additive into that soil on that land to supercharge the natural recovery of that PFAS? Is that what we're talking about here?
Yeah.
Or, okay.
So the way the technology works, there's a couple different ways that biology can work. One way is that they're excreting things like enzymes that are breaking down the contaminant so that they can consume it and use it as a food source. That's one way. They can also evolve to do that in inside their process. So they can also like think of it as PFAS as food. So they consume the PFAS. They've evolved to break that down to use it in their metabolism like we would any food source, and it breaks down into inert contaminants. So there's a couple of ways that that organisms can work, but basically they're using it as part of their sustenance, and they're using what's around them. That's what they have. They want to survive, and so they're going to evolve, which I think is fascinating, so that they can use what's in their surrounding to survive.
Wow. So you'd basically train the microbes so they'd have a diet of PFAS.
Yep.